Okay, welcome back. So, as we have started earlier, the last topic that we have in this chapter is the concept of selectional preference. And as we have said earlier, whenever you use words in a context or in a sentence, words do not occur randomly. They have some kind of preference. Words might prefer the word that they want to occur with. Because in every language we are very selective on the words that we use. ለምሳሌ ምን እንላለን? እንጀራ ብለን most of the time ምን እንላለን? ወጥ ማለት ልምዳችን ነው አይደል? እንጀራና ወጥ ለማለት አይደለ? እንጀራ ብለን ይውጣልህ እንላለን አይደል? ለምሳሌ እንጀራ ብለን በቀላ አንልም. We don't say that. Because in the language we know that some words prefer a kind of word they occur with. And it's common in every language. And that's what we mean by even the term itself is very descriptive, right? It says selectional preference, which means words prefer, selectively prefer with what kind of word they want to occur with. So as we said, most verbs prefer arguments of a particular type. Okay, for instance, the word bark prefers to occur with the word dog. I don't know. Does it occur with the word cat? Zanaba. Can it occur with the word cat? It can't, I don't know. It can't occur with the word cat. So words would prefer. And such kind of constraints, such kind of rules is what we call selectional preference or selectional restriction. And this is very important. What if the word dog is not part of your machine readable dictionary, for instance? Dictionary ላይ ላይኖር ይችላል, but you can have it in the corpus. You can have it in your documents. But the definition might not be available in a machine readable dictionary. So in such kind of cases, if you have a database of a selectional preference, then it will help you, to pick that word, even though it's not part of the dictionary. So if a word is missing from our machine readable dictionary, aspect of its meaning, you see, aspect of its meaning can be retrieved from this selectional preference. Aspect of malat, not everything, but some part of it. So if a word is missing from our machine readable dictionary, aspect of its meaning can be inferred from a selectional restriction or selectional preference. So it can be used even to rank, some parts of a sentence, or some phrases of a sentence can be ranked based on that. So as we said earlier, selectional preference is a mechanism to capture or constrain a possible meaning of a word in a given context. So if you say, as we said earlier, the word dish can have multiple meanings. It might mean the utensil that we have in a kitchen, ሳህን ማለት ነው, or it can be a meal. ምክንያቱም dish የሚለው በእንግሊዘኛ can have multiple meanings. But if it occurs with the word wash, okay, ከwash ጋር appear ካደረገ, what does it mean? You cannot wash a meal. Definitely it should be the utensil or the object. So in this case, the meaning of the word is referring to the object. The meaning of the word dish is referring to the object. But if it says cook a dish, we know that we cannot cook a utensil, rather that it is a meal. So if it occurs with the word cook, then we can say it is referring to a food or referring to a meal than an object. And this is what we call is selectional preference. Words would prefer the kind of words they occur with. So the sense of the word dish in this case, if it is to mean a food, then we know that it occurs with the other word, which is cook. If it is referring to the object or the utensil, then it would occur with an action of washing or an action of breaking. Or you can say break a dish. In that case, it doesn't mean food. It must be the utensil ማለት ነው. So capture information about a possible relation between a semantic classes where words are associated with these classes. So as I said earlier, selectional preference can also be acquired from an annotated corpus. If you have an annotated corpus, then you can actually develop selectional preference from that one. But people say that they have some kind of a circular relation, which means it's just like the chicken and the egg conundrum, right? Which comes first? Is it the chicken or the hen? The chicken or the egg. So sometimes we need a word sense disambiguator to build an annotated corpus, or we need a selectional preference also to devise a word sense disambiguation. But the preference, whenever you want to build such kind of selectional preference using a raw corpus, most of the time we dwell on frequency count. How many times a word occurs with another word. So you can have such kind of statistics. You can have the word dish, but it can occur with the word cook, or the word dish can occur with the word wash. Okay, now the question is, how many times do you have this occurrence? Okay, so for example, it can occur with this one, let's say 120 times, and it can occur with this one 80 times. So what does it mean? The word dish occurred 200 times, but from these 200 times, it occurs with cook 120 times, and it occurs with wash 80 times. Now the question is to come up with a conditional probability. And what does that conditional probability? So we are interested about the probability of having the word cook where it appears with dish. This is one. Or the probability of wash where it occur. I mean, we already know that the word dish has occurred. So in this case, we are going to make a count. The count is we're going to count the number of times cook occurred with dish, divided by the number of times we are going to count the number of times the word dish occurred. Okay. Conditional probability, and we can calculate it in such a way. This means this is going to be 120 over 200. Okay. And in the second case, this would be equal to count the number of times we have the word dish or wash with dish, how many times it occurs, divided by count the number of times you have the word dish, which is going to be 80 over 200. So whichever is the highest, you'll say this is the most preferred occurrence in the LLM. So in this case, we'll say the word dish prefers cook than wash. You can say this based on how many times it occurs in the corpus. So you can have statistics or a conditional probability to see which one is the most preferred word that co-occurs with the ambiguous word that we have. So as we said earlier, you can do the counting. Word one with word two with a specific relation, then word two with a specific relation. So in this case, the relation might be, the kind of information that we want to perceive, capture. So an indication of a semantic fit between two words, you see, we want to see the semantic fit, how one word is fit with the other semantically. We can actually count or perform a frequency count, pair of words connected by a syntactic relation. So word one and word two with a specific relation, how they are related in Milan. Then whenever you have more than one word, because you can also have another word with the same kind of relation, you can count, for instance, word three with word two using the same relation, okay? Word three was word two with the same relation, and the conditional probability, look at the calculator, then it means what is the probability of word three, okay, given word two is in that relationship, and this is equal to, we're going to count the number of times word three and word two are related with that relation, divided by, then we're going to also count the number of times word two with that relation. So we want to see how word three, so it means in a way we are comparing word three with word one, because word two is relation already occurred. Then now we'll say word two is either highly related with word one or word three, then we can make a preference using the conditional probability that we have in here. So selectional preference can be done in such a way. So you can calculate such kind of a statistics. You can determine the contribution of a word sense based on the assumption of equal sense distribution or sense proportion. So the word plant has two senses. 50 times it occurs as one sense one, and 50 times it occurs as sense two. This is a normal or random, or we can say a fair distribution. But we know that if you use a corpus, that's not always the case, because a corpus is going to make a count. So you can learn the restriction of a verb to drink, for example. To drink is a verb that can occur with many other nouns. But what if I want to build the most preferred word that cannot occur with the verb or the action to drink? So what we're going to do is, from a corpus, I'm going to count how many times drink occur with tea, drink occur with Pepsi, drink occur with champagne, drink occur with liquid, beer, and wine. And I can produce the co-occurrence score with such a case. So what if you don't have the word እንደዚህ አይነት ነገር ቢኖረንስ? Okay, what if you have such kind of a case, drink below, then you don't know what comes next. You know, to some extent, the concept of language modeling would also be used in here. So in this case, from these ordered co-occurrence statistics, you can say it is more likely that either it is a tea or Pepsi or champagne. But we know that it cannot be wine based on the statistics. As you can see, the co-occurrence is 9.34 compared to the others, which is 11.7. So you can build such kind of, you know, co-occurrence statistics for this purpose. So as we said, you can also have unsupervised sense clustering, which means grouping based on the neighboring words. We have seen an example using the Amharic ambiguous word Gana. Or you can use a semi-supervised, which means you can combine the supervised and unsupervised approach, which means a small number of the data would be labeled, and the other most, you know, the larger part would be unlabeled. So from the labeled data, you can build a model. Okay, you can build a model from here. Okay, and this model can be used to classify the unlabeled model. Immediately after the unlabeled model, unlabeled data is labeled using the model, we are going to develop another model. Okay, this is what we call is a semi-supervised approach. Some part of it is supervised, the other is not supervised. Then we try to combine this one. And the third one is a dictionary-based, which we have seen earlier. And the Lesk algorithm is one typical example for this one. Now, the final part in word sense disambiguation is how you will be able to evaluate it. Okay, whenever you develop any NLP application, we have said that it has to be evaluated. And one of the approach is you can use a fixed and same training data and test set for this purpose. Then the system can, whenever the sense tag is not found, then, or whenever it is not sufficiently certain, then it will say it will decline. But the idea in here is to measure the efficiency or to evaluate your word sense disambiguator, you need to have these three counts. The first is you need to have the total number of test words. The test word is the one for which you need disambiguation to be done. Then from this total number of test words, one is we have the number of words that are assigned a sense. Mind you, your model can assign a sense, but some of them might be wrong, or some of them might not need a sense at all. The other one is the total number of words that are assigned a correct sense. So in a way, the number of words that are assigned a sense means what has been displayed. Here, this is given as an output by the system. But the system output because those are the words that the system assumes are ambiguous and sense is assigned to them. Like information retrieval, like all the documents that are displayed in the mallet, but we know that some of them are relevant, some of them are not relevant. So number of words that are assigned sense are the total number of output. Okay, it is total number given as an output is what we call A. The other one is the number of words that are assigned correct sense. So from the total number of given outputs, which are correct outputs mallet. Okay, it's a correct output is what we call C. And T is what we call the total number of test words. Okay, the total number of test words, which means the test words for which, okay, the sense should be assigned to. So precision means it will be C over A, because precision is concerned about precision is concerned about purity of the output. From the output, how many of them are correct in precision? So the output is A, the number of words that are assigned sense, which means the total number given as an output is A. And C is the total number of words that are assigned the correct sense. So C over A malet, from the total output, okay, that's what we mean. From the total output, A is the total output given. How many of them are correct malet, no? So that's what we call as precision. Recall means from the total number of correct senses that are given as an output, from the total sense that should have been given a tag or an output, how many of them are actually given malet? Because recall is concerned about coverage. Recall is concerned about giving all correct results. From the corpus or from the test data, recall is concerned about identifying all correct results. Mind you, ሁሉንም ሲያወጣ ግን it might also bring some jargons with it. But recall is not concerned about the jargons that are given as an output. The concern of a recall is make sure that all correct results are put as an output. ስለዚህ ከፒዩሪቲ ይልቅ recall is concerned about coverage. So from the correct that are given as an output, from the total output that's expected, how many of them are actually given? From the total that are expected, how many of them are actually given የሚለው is what we call the recall. So you can evaluate your word sense disambiguation with this one. And with this, we're done with the fourth chapter, which is word sense disambiguation or semantics. So when we meet tomorrow, we'll move into another interesting topic, which is machine translation, which is topic 5 or topic 6, I think. I think it is, just give me a moment. It is topic 6. Mind you, as I said earlier, topic 3 and topic 5 will be covered face to face. So that's what we are going to discuss tomorrow, okay? Do you have any question? Any question?
Yes.
Okay, Zanaba, you can unmute.
Yes. From context features, we have about 4 elements to determine the sense disambiguation.
The context feature, we said we have 4 types of contextual features, which means a feature that you can extract from the context. Mind you, context means the sentence in which the ambiguous word appeared.
Yes.
Okay.
And so experimental evaluation says that the 4 must be integrated to get the required best output. So from the first one, surrounding bag of words, we only need the root words, or what can as after
removing the affixes. Yes.
Yes, this is the second one. Not need to remove the stop words or
yes.
What can anything
because it is only talking about the part of speech. In the part of speech, we don't have any affixes, right? Either it's a noun or a verb. Okay.
Yes. And the third one also don't need that.
Yes.
The fourth one also needs,
yes.
especially the lexical algorithms needs.
No.
Need
no. The syntactic relation does not need a stemming. Because if you do stemming, then the part of speech might change. ለምሳሌ አንድ example ብሰጣችሁ, you have the word, let's say, killer or runner ብለን እንያዝ. If you do stemming, er የሚለው ሲጠፋ ምን ይሆናል? run ወይም kill ይሆናል. So the word which was a noun has changed to a verb. ስለዚህ እንደሱ ካደረጋችሁ, mind you, the syntactic feature ምንድን ነው የሚለው? What it says is look into whether what kind of noun it is modifying, or for what kind of object it is a verb to, አይደለ? ቼክ አድርጉ የሚለው. So if you do stemming, ናውንነቱ ይቀርና verb ከሆነ, then you cannot find the noun that it is affecting. So stemming ልንሰራ የምንችለው most probably it's only for the first one, which is concerned about bag of words, simply the list of words that are around it ማለት ነው።
ስለዚህ እነዚህን አራቱን ኢቫሉዌሽን ላይ ያው መጨረሻ ላይ ኤክስፐሪመንታል ኢቫሉዌሽን ሲደረግ ጥሩ ውጤት ሊሰጥ የሚችለው ኢንተግሬት ስለሚሆኑ ግን እነዚህን ማጥፋት ያለብንን ነገሮች አንዱ ላይ አናጥፋም፣ በአንዱ ላይ ደግሞ
እንታፋለን።
ስለዚህ እንዴት አሁን በአንዱ ይጠፋል በአንዱ ደግሞ አይጠፋም፣ እንዴት መጨረሻ ላይ ጥሩ ውጤት ልናገኝ እንችላለን? ምን ጥያቄ
ለመሰለ የምንለው mind you, we are not saying all of the four should be combined እያልን አይደለም። What we are saying is experimentally people have found that if you use only one of them, for instance, if you only use part of speech of the neighboring words, you can get some level of accuracy. But it might not be enough. So most of the time people, what they do is they don't combine all the four. They will combine maybe two of them. Combine ሲያደርጉት, mind you, you are having more information. Like if I use bag of words and part of speech of the neighboring words, what does it mean? I have more information about the ambiguous word. በምን አንደኛው I have seen words that are around it. ሁለተኛው ደግሞ I also have seen the part of speech that is found before and after it. So if you have more information, what does it mean? It means it would be much easier for you to make a decision. You are going to be more certain about the decision that you make. ነገር ግን if you combine all the four, of course you might get a better result, but it would be very computationally very costly. ያን ሁሉ language feature መሰብሰቡ for your program it's going to be really difficult, because as you have seen, the information that we collect for all of them is quite different. In the bag of words, we are looking for words in the current sentence or even in the previous sentence. Simply collect words. In the part of speech, we are concerned about only the neighboring part of speech. ስለዚህ ምን ይፈልጋል ማለት ነው? It needs part of speech tagger. የእያንዳንዱን word part of speech የሚነግርህ ሌላ ሞጁል ትፈልጋለህ, which is an additional cost. What if you want to do what we call collocation? Collocation is concerned about only adjacent words. The previous sentence ምናምን አይደለም, unordered sound immediately to the left and to the right of the ambiguous word ነው የሚፈልገው. What about syntactic relations? It looks for additional knowledge. ምን ብሎ what kind of verbs are modified by this, what kind of nouns are modified by these adjectives? What kind of verbs can be used for this noun እያለ additional knowledge base ይጠይቃል. So if you need more knowledge base, it means your program is going to be complex. But mind you, if you combine all the four, you might get the best result. But it would be really costly. If you remember, we talked about the Lesk algorithm, right? Lesk algorithm, like, why did we move for the simplified Lesk algorithm?
time consuming.
Time በጣም consume ስለሚያደርግብን, we are going to lose some accuracy, but we'll go for a better, a fast word sense disambiguation using the simplified Lesk algorithm. Okay? Any other question?
Another question.
Okay.
We need a backup of words in order to make our words, sentences more interesting. And also we need n-grams or unigraphs. Why we need unigraphs and grams and n-graph other than bag of words.
Now let's see the difference between these two. Okay, what's the difference between the two? The first one is we say unordered bag of words. Okay, what does it mean? What do you mean by unordered bag of words? No, anywhere in the sentence. Okay, if you remember እንደዚህ ብለን ነበር አይደለ? As an example, this is what we have said.
But for you,
እንደዚህ ብለን ነበር አይደለም? Where is the ambiguous word? This is the ambiguous word. But bag of words እነማን ናቸው ብለናል?
Used.
used አይሆንም። Hit, ball, baseball, and game. You see how far the ambiguous word is from the word game? ያው 1 2 3 4 5 6 7 8 ዘጠነኛ ላይ ነው ያለው። Okay, what if I have this one? The player used or the player hit the ball using the bat. ብዬ ባስቀምጥስ? What are the bag of words? Player, sorry.
Hit.
Player.
Ball.
Hit. Ball. አይደለም? እነዚህ ናቸው። Now you see, player is further away from the ambiguous word. So it doesn't matter where it is ማለት ነው። Unordered ያለው ለዛ ነው። It can be anywhere. Mind you, the same bag of words እንደዚህም represent ላደርገው እችላለሁ። Okay? It doesn't matter where it is. Okay? Bag of word means simply put the words into a list ማለት ነው. So this is what we call is unordered bag of words ያለው. What about local collocation? አይደል ያለው?
Yeah.
Local collocation is concerned about, that's why we say in local collocation we are concerned about n-gram. So what does it mean? We are interested about a specific number of words to the left and to the right. For instance, what if I have bigram? Bigram ቢሆንስ? It means I'm interested about 2 words. So let's take this sentence. Okay, let's take this sentence. And I'm interested about, we should remove the stop words. ስለዚህ stop wordዎቹን እናጥፋቸው. Okay, stop wordዎቹን, let's remove the stop words. So if you remove these stop words, this is what we have. Now, to represent the ambiguous word, ሁለት word ነው የወሰድኩት አልኩኝ አይደል? If you remember, we said እንዲህ ብለን ነበር. It can be C -1 እና 1 ሊሆን ይችላል, ወይንም C -1 -2 ሊሆን ይችላል, or C 1 እና 2 ሊሆን ይችላል ብለናል አይደል? Which means if this is the ambiguous word, ለምሳሌ ይሄ ነው ካለን -1 and 1 ማለት 1 to the left and 1 to the right. That's what it means. If I say C -1 or -2, if this is the ambiguous word, ሁለት ወደ ኋላ ማለት ነው። C1 to ደግሞ ማለት, if this is the ambiguous word, 2 words to the right of it. That's what it means. So in this case, let's take, for instance, C -1, 1. So this is the ambiguous word, right? Before the ambiguous word, ምንም የለንም. After the ambiguous word, hit ብቻ ነው ያለን ማለት ነው. You see? Okay. This is the feature that I'm collecting. What if C -1 -2 ብጠቀም?
-1 ወደ ኋላ.
This is C -1, 1 ነው አይደለም? What if I use C -1 -1? -2, I mean. ምን ይሆናል? null ነው የሚሆነው, because to the left of the ambiguous word I don't have anything. Okay? What if I use C1 and 2?
1 and 2. Hit.
And ball.
Ball.
You see? Hit and ball ይሆናል. You see? Now local collocation is concerned about only list of words that are adjacent to the ambiguous word. But bag of words doesn't care where it is. It can be to the left, it can be to the right. It can be the first, it can be the last. As long as it is within the same sentence, you can collect it as a feature ማለት.
Thank you.
Did you get the point?
Yes. Thank you very much.
Very good. Okay. Any other question? Are the concepts clear for all of you?
Dr. Bagov, word እንትኑ አሁን ወደ ሪሰርች ስናመጣ ምናልባት አሁን ዲስአምቢጊቲ ለመፈለግ ይመስለኛል ሁሉም እንትን ምናደርገው
ምን ለመፈለግ
የወርድ ዲስአምቢጊቲው ለመፈለግ
አዎ
መሰለኝ የወርዱ ዲፊኒሽን ቀጥታ
አዎ
ስለዚህ እንደዛ ስናደርግ አሁን አብዛኛ ምናልባት እንግሊዘኛ ላይ በጣም ብዙ የተሰራ ይኖራል
እሺ
ሎካል ወርድ ላይ ሎካል ላንጉጅ ላይ ከሆነ ምናልባት እንደዛ ማናገኝ ከሆነ ያ ዲፊኒሽኑ በራሳችን እንደ ኮርፐስ አርግን የምንሰጣቸው ቃላቶች ናቸው አንድ ዲፊኒሽን ለማግኘት
ኖ ኖ ሁለቱ እኮ የተለያየ ነው ሌክሲክ አልጎሪዝም እና ይሄ የተለያየ ነው the one that you need dictionary for is lexical algorithm ይሄ ሌላ ነው ራሱ ቢልድ እንዲያረግ ከፈለክ ነው this can be used mind you this is what we call is a contextual feature by looking into the words that appear in the same sentence you can build your learning model አሁን ቀደም ባየነው መሰረት ምን ይላል whenever the word ball whenever the word bat appears with ball player heat it is referring to the baseball game below or the one that you use in sport ይላል whenever it occurs with fly animal night mammal because the definition of or the sense of the word bat as the animal would appear with such kind of words አይደለም ስለ አኒማሉ ቢሆን ኖሮ ምንድን ነበር የምንለው the bat was flying on top of this the bat came out of her nest at the night ምናምን ነው አይደለም የምንለው እንጂ we don't have the words like heat player game የሚል አብሮ አይኖርም so your learning model ምን ያደርጋል whenever the word bat occurs with play heat game ከሚለው ጋር appear ሲያደርግ it is referring to the football bat whenever it appears with night fly or something like that it is about the bird bat ብሎ knowledge ይዛል ማለት ነው then after that whenever you give it a new sentence ምን ያደርጋል it looks into the words bag of word idle concept it looks into the bag of words in the same sentence in the context ማለት and if it is either of the two either player heat game የሚል ነገር ካየ then it is a sport ይልሃል or if it finds fly mammal or ምናምን ካለ ደግሞ it will say it is the animal bird so it means you are building a machine learning approach and you can do the same thing for any of the language because you know that words would occur with other similar words they prefer to አይደለ አማርኛ ላይም ወላይትኛ ላይም ትግርኛ ላይም ግዕዝ ላይም any language ብታዩ we know that ambiguous words even though they are ambiguous whenever they are used in a context or in a sentence the kind of word they occur with would give you some clue about the sense ለምሳሌ the word bank is ambiguous right financial ነው የምትሉት መቼ ነው እዛው ሴንቴንስ ላይ payment cash ምናምን የሚል ነገር አብሮ ካለ then it means it's referring to the financial institution what about ውስጡ river mountain የሚል ካለስ it is referring to the river bank rather than the financial bank and that's what we mean by a contextual feature okay
thank you doctor
okay any other question okay if you don't have any question then tomorrow we are going to start machine translation which is a very interesting topic so make sure to read something about it okay thank you I'll see you tomorrow
Thank you.